and welcome to tonight's The Bridge Show. And what a show we have for you again. It's Tuesday and we're back. So let the show begin. And welcome to Bridge Technologies IP studio in the basement of our HQ here in Oslo, Norway. And we have in the red chair, Rolf Ollmar.
Thank you, thank you.
Welcome to the show.
Well, thank you, thank you.
You've been here quite a while, quite a lot.
Yeah, a few times.
Yeah, I say.
Yeah.
And every single time we have something particularly technical.
Well, maybe, yeah.
Oh, yeah, well, we try to get you on.
Yeah. I've tried to grow a beard for this occasion.
That's very nice.
Because today it will be about RF.
That is, oh my God. Everybody's a comedian when they come to this show, so, but that's a good one. We are going to talk about RF.
Yep.
In particular, we're going to talk about terrestrial.
Yeah. They will be T2 networks.
That is very, very true. And why is this pretty acute these days?
Yeah, I mean, we've all heard about 5G.
Yeah.
The rollout, of course, that means pressure on the frequency bands.
Yeah.
And particularly the 700 megahertz band is being sort of pulled away from our
yes,
our domain in a sense. But
give it to the telcos.
Yep,
Shame on you.
So, and that of course means that a lot of activity is now taking place in pretty much all the terrestrial systems out there.
Yeah, because they have to basically then move everything out of that band and consolidate the normal broadcast bands.
Yeah, it's a big reshuffling going on, and they all have to fit more into less space, basically.
Yeah. And well, some benefits it is, of course, because then a lot of people are revamping their networks. And today we are talking about DVB-T2, of course, because that is the flavor that everybody chooses these days.
Yeah, I mean, that means more into less. It's the modern way of transmitting digital television over air. Of course, they have different standards in different parts of the world. In the US, they are doing the ATSC 3.0 thing. Here in Europe and in a lot of other Asian countries, we are doing the T2 specifications. Yeah.
I'm not going to diss T2 because we love DVB. They're a beautiful standard organization. Been they're active for 40 years. Well, 30 years. I may have been a bit too overblown there, but ATSC 3.0 is quite interesting as well.
Oh yeah, definitely. It's using a lot of the same techniques that are already in place in T2, but of course with the American adaptations and spins on it. Yeah.
But they also have an IP layer.
Yep, exactly, and exactly like I mean, you see the same parallels between ATSC and T2 with these what they call conduits or pipes.
Exactly.
And in T2 it's called T2MI.
Yeah, and let's get the first diagram up, because basically there is the diagram that shows in a very simplified way the main broadcast head end, and then the transport network, and then the different sites. But as you said, you're tunneling over the network.
Yeah, and these tunnels, they are not only created for sort of linear traditional television, you can also use them for other data traffic, basically.
Exactly.
So it's a kind of future-proof specification in that manner.
Yeah, that's very true, because again, as you say, you have tunnels, so you have full control over aspects like what do you put in them, of course, but you also have great control over timing.
Yeah. I mean, all of these networks, they rely on perfect synchronicity. And in particular, if you are doing what they call SFN, single frequency networks, which is basically being able to have multiple transmitters sending on the same frequency and within each other's range.
Because in the old days, if you had two transmitters, which was kind of inapproximate, you couldn't really transmit over the same frequency because, of course, that will
you would
just destroy the signal.
Yeah, exactly. You'd see ghosting and all kinds of weird analog effects. Yeah.
So T2 provides then synchronization, so provide that you basically have two transmitters saying on, off, on, off, on, off.
Yeah, it's exactly that. It's like a metronome in a sense that ticks at a constant time, and then all the transmitters will wait for their start signal, and once they receive that, they will all transmit at the same time.
Yeah.
And in this way, you avoid interference because the signals they enhance each other instead of killing each other.
That seems like, second resolution is not good enough, maybe not milliseconds either.
No,
microseconds.
It's down to micro and sub-microsecond level type.
Nanosecond level.
Yeah, it's the GPS resolution is 100 nanosecond granularity, so you need to be in the microsecond range to be able to do this. Yeah.
Well, let's bring down the next slide and go into detail on one of the sites, because a site will then consist of typically, as you said, it's coming from the network. So it's either coming as an IP signal or via a transport converter into ASI.
Yeah, I mean, those are the two preferred ways of getting the signal from the master site to all the transmitter sites. So you either run it across an IP-based infrastructure, which is the modern way of doing things, and most operators are doing this or are in the process of switching over to using IP. You can also use ASI conduits. It's the same information being carried, but in a different manner. The physical layer is different. Yeah.
And that means that it either goes through a converter or it goes then at least into the modulator, which is the main kind of business here, or the business end, if you like, of a site.
Yeah, that's the transmitter location. So then the signal has been through the primary contribution as a T2MI conduit or pipe, and the T2MI layer gets stripped away, and the signal itself, the transport stream, is being fed into the modulator and creates the RF signal that we're used to, that is then amplified and pushed out onto
the transmit tower.
Yeah.
But we're in the business, of course, of monitoring this. So let's bring down the next one, because then we fitted our monitoring solution, which is again very popular. We have a lot of deployments out there.
Yeah, I mean, this is something we've been doing for many years. I mean, the first T2 deployments we did was in 2012, I believe. And,
that's so true.
Yeah.
That is amazing. It's a long time ago.
Yeah, and that's what's a bit interesting these days, with the 5G being a driver or for this renaissance within T2 applications, in a sense.
And that means that they have a reason to modernize, to also bring, of course, much of the network, which sometimes has been, ATM-based, etc., over to IP.
Yeah, definitely. Yeah. So that's exactly it. So we supply monitoring into these transmitter towers. Our preferred solution is then the VB120 with the 252 module in it.
As we see here, actually.
Yeah. So that's a classic system where you have a modulator, a transmitter, and we can look on the signal, the T2MI on the far left there, and we can look at that signal coming in as T2MI. We can also see the same signal after it's been through the RF chain.
Exactly. And that means that if we stay on that slide for a second, because basically that means that when you then use the super accurate local GPS clock and synchronize our device with the modulator, we'll be able to see then exactly how the performance of the modulator and the transmitter, of course, is.
Yep. Yeah. I mean, one of the key areas here is synchronization, and we can now compare the IP layer with the RF layer, and one of a very practical or a very real-life problem in these areas are synchronization. You will always have multiple vendors of transmitters, modulators, You might have different vendors of T2MI gateways. So all of this brings into a need for checking the consistency of the timing.
Exactly.
So that's what we do.
Because that's all, that's, you know, is the main purpose, to be able to validate that the strict timing coming on the input doesn't get delayed by anything at all on the way, so that you can provide then this acute synchronization method in the physical transmitter.
Yeah, yeah, that's exactly it. Yeah.
Well, it's not getting simpler by the years.
No,
it's
not. Yeah.
Holy Moses.
Yeah.
Well, let's go one step further, because this is one typical you know, site, and get back to the simplified diagram. Of course, as an example, you know, we built the TV NRK or Nordkring, basically, network here in Norway.
Yeah, we were involved in that network. Not all of it, of course, but some areas on the master transmit sites we've been involved in. Yeah.
And they have quite a lot of sites.
Yeah, I mean, typically it varies depending on the geography. In Norway, we have lots of mountaintops.
Yeah, of course.
So we have, I think it's close to 400 transmitter towers all across. Yeah. Whereas if you look on other geographical areas, where
Denmark,
yeah,
maybe?
for example, that's not so much mountains.
No. Do they even have mountains?
Oh, they are, I've been told they have. So,
Okay,
yeah.
cool.
So,
we go skiing in Denmark next time. Yes.
Yeah, so they have something, I think it's 20, 25 transmitter sites. Yeah.
And that covers the whole country.
Yeah.
So if you bring back the diagram, we can actually see that we just have two sites, but it kind of illustrates, and there's always, you know, a central location where the signal is produced. And we've been talking quite a lot about the release of the VB330 version 6 appliance the last 2 months.
Yeah, that fits perfectly into this as well. It's in a very typical system like this with IP in the core.
Yeah.
There is a need to look at these T2MI conduits or pipes and to unwrap them so that you can check what is being carried inside of them.
Exactly.
And that's quite a CPU intensive job, and it's something that you would typically want to do one place and for all the streams concurrently.
Yeah, because you would like to see you know, the streams individually. You would like to see them, you know, then post muxing, and then of course pre and post T2MI tunneling.
Exactly. Yep. So that's exactly what the 330 can give you.
Yeah.
You can then look at the same signal, but at the different stages in the head-end processing. Yeah.
And then, of course, you know, we have one more diagram on this one, which basically also says that then you can correlate from then the main head-end and all the different sites, and actually see exactly what is, if there is any change, which hopefully there isn't. But if there is any change, you will then be able to spot that immediately. Yeah,
yeah. We have the VBC, the Video Bridge Controller, which is our go-to control system in a sense, the umbrella system sitting on top of all the monitoring probes. So this gives you a very good way of looking at correlating data between the points. In many countries, they even have demands that you must monitor to a certain level, and you must create SLA reports so that you can document the quality of your transmissions. It's written in law basically, and so this is something that you could achieve by using the VBC. Then you can auto-generate reports, etc.
Yeah, because terrestrial television is not really like, you know, just for fun.
No,
it's actually you know, pretty critical for nation states.
Yeah, that's one of the things with broadcast technology, because it is and has always been a key infrastructure in national security and way of getting information to people quickly. So that's not going to go away for a while.
Well, since we're talking about infrastructure and of course broadcast television, because we do have some culture, which of course the terrestrial television is, they transmit quite a lot of it.
Yeah, they do.
So we are going to let our mad musical genius take us into some fantastic music from a Norwegian composer, and of course providing you here on the Bridge Show the same quality culture you can get on a terrestrial network, or maybe even better. Take it away, Axel.
Hola, ¿qué tal? Buenos días a todos y bienvenidos a todos. Mucho encantaba. Today, we're going to talk about something mucho beautiful. Me. See, it's like I see myself as El Toro Ferdinand, Ferdinand the Bull. It's like the VB330, no? Silent but beautiful. So I tell you the story about me and Ferdinand the Bull. Había una vez en España un pequeño ternero de nombre Ferdinand. Okay, so obviously today we're not going to talk about me, but mañana.
Oh, that's very, very beautiful. So I say, you know, thank you to Axel, and of course thank you to Susanna. Beautifully sung. So, but we're not finished yet, Rolf. We have one more, you know, part of the technology, because you talked about single network frequencies. And we had talked about then monitoring points along the distribution chain, of course. Yeah. But we have one more, and you sometimes put it as it's not it's a easier solution to monitor, if you like.
Yeah.
But it's a bit let's say waggly as well. Can we put out this slide that we have, because here you can see that we have then two transmit sites, and then you place some monitoring in between them.
Yeah, this is often called off-air monitoring, and it has its advantages and disadvantages. The whole idea here is to, in a typical SFN environment, you put an antenna in the air and you try to put it somewhere in between all your transmitters, some central location. And then you try to receive the signal at the same time. So it acts like a super user in a sense, a user that receives everything at the same time.
And that means that you can see in a very precise manner exactly how those two transmitters intermediate with each other, or worst case interfere with each other.
Yeah, you can get it's a way to look at synchronization and use something called channel impulse response diagram, which is basically just a graph showing a peak for each transmitter, and you can watch this peak in time and correlate them against a known mask that you expect. Of course, it suffers from things like the weather and and also stuff that comes in between, and these kinds of things. So
snow,
snow,
sleet, fog, even absolutely interferes with RF. And not a day. I think that every single time you've been here, we showcase the amazing Nomad, because the cool thing is that also have, of course, DVB-T2 inputs.
Yeah, I mean, everything we talked about today can be done with such a unit, as well as the stationary one.
And of course, this one combined with an antenna and a battery pack, you can place yourselves anywhere between two transmit towers.
Yeah, yeah, you can on your little moped. Yeah.
Exactly, measuring. Yeah. Well, it's not a bad idea.
No, it could be.
Continuous signal coverage diagrams. I think that's an interesting thing. So yeah, pick it up, you transmit guys. Maybe a moped and a Nomad could do the trick. Yeah. Or maybe not.
Maybe not.
Well, that's all we got. Of course, if you want more information about our deployments and our technology, please go into bridgetech.tv, our website. And of course, if you want to continue to have fun every single Tuesday, don't forget to subscribe to this channel. I hope that you enjoyed this one, which has to do with the terrestrial transmissions. And thank you, Rolf, very much for coming.
It's a pleasure.
We'll find some more advanced topics to talk about, so good. You'll be back. And in the meantime, have an amazing week.